All right. Doesn't look like anyone else is trickling in. Let's see. This week has been mostly reviews and a few SeaStore bug fixes last week for me. I'm trying to get a measurement environment set up so I can see the numbers you've been seeing, Yingzhen. I'm going to start looking into SeaStore write amplification and the garbage collector. Also ZNS. I finally got an environment set up for that. That's it. Yingzhen, what's up?
Last week I wrote a POC to address the transaction conflict issues. And I also confirmed that the Ono tree fixed parent is not a problem yet. But I still think Ono tree might was a major refactoring and also needs to be simplified. And yeah, I think this week I will also try to update the metrics to consider the out of line extents correctly. That's all.
Cool. Sorry about the bitwise hash thing. I completely forgot. It's been a few years.
No problem.
I think that should get us down to the transaction conflict level that's appropriate for a decent quantity of data. With any luck, that'll clear up like a lot of stuff. Most things should behave better.
Mm-hmm.
All right, Chenmei.
So last week I tried to trace the iterator next and found that OMIP occupy most CPU cycles for the allocated extent, and Yingxin has already fixed the missing hint. Then I tried to retest again, and the allocated extent is very low. Currently, it occupies very low CPU cycles, and most is the kernel system call and C-star. For the Crimson, only catch, extend, prepare, write. So that is the first one to occupy most CPU cycles for Crimson code currently. And but it is not very big in the low workload. In the light workload, for example, IO depth is 2 and the number drops is 1. It is only about 2.5%. When I increased the workload, 16 IO depths, number drop is 1, and it's about 4.5%. So, but even our code not occupy most CPU cycles, but the latency is still worse when the workload is increased compared with the Ceph OSD and the BlueStore. So when the IO depth is 2 and the drop number is 1, in this situation, our write is better, about 1/3 of the Ceph OSD and the BlueStore.
So at a guess, what's going on is we're not doing journal batching. BlueStore does a lot of work so once there's enough stuff in the BlueStore journal, every journal commit's going to tend to include multiple transactions, not just one of them, which tends to speed things up, I think. I suspect we will need some kind of journal batching as the next step.
Journal batching. Oh. Okay.
At a guess, that's the next thing we'll want to do. If you look go ahead.
In the low light, in the light workload, I mean the concurrency is small. Our write latency is better than Ceph OSD. I said the Ceph OSD use just one thread for the messenger. Every part is one thread, and band the process to the one CPU. So the in the light workload, the write latency is better. But when the concurrency increased, our write latency is worse very much than BlueStore.
Yeah, that's consistent with write batching. So when we're submitting one disk barrier for every transaction, but with a high degree of concurrency, we should be only issuing a barrier every couple of transactions, and then completing them all at once. That's what BlueStore does with its what's it called? The sync write thread, I believe. It submits very large transactions to RocksDB, which has the effect of allowing RocksDB to do a very large compound commit. I suspect that's what we'll need to do next.
Okay.
Yeah.
Okay, I see. And
If you're interested in looking at it, the relevant code would be in journal.cc. Where we submit to the segment manager, we would want to submit, instead of one record, we would want to submit multiple records at once.
Oh, okay.
Or something. It will need there will need to be some kind of refactoring in journal to support this. I'll get to it eventually, but if anyone's interested in taking a look in the meantime, that's what we probably want to do. I'm trying to think of a way to prove that this is the right fix, but we almost certainly want it anyway, so it's probably worth implementing, period.
And for the read latency, it's weird. And the light workload, in the light workload, the crimson or read latency is worse than Ceph-ST. And increased concurrency, the read latency is better. And I can't increase much workload because I meet the same Ceph alert as in scene report, the block IO wait, something like that.
So the reason for that one is almost certainly that SeaStore doesn't do any meaningful caching yet. If you go look at cache.h, you'll notice it doesn't actually have an LRU. All it does is keep any dirty extents in memory. So we tend to evict big chunks of the LBA tree for no reason. We probably shouldn't be. So that would be the place you'd want to look if you wanted to address read latency.
So you mean the read latency is worse because we didn't do the cache?
Right.
Caching.
The machinery is there. Basically, all that needs to happen is cache.h needs to gain some kind of an LRU to maintain a reference to a limited amount of extents at any given time. The rest of the logic should be identical. It's just a matter of adding another reference tracker.
Okay.
That is, we already have the cache itself. We have the ability to keep extents in memory indexed by physical address, but we let things fall out of the cache the very second there aren't any active references to them if they're clean. So what we want to do is keep, 256 megabytes, a gigabyte, something like that of the most recently used extents. That's probably the first step. After that, we'll want to get clever with our caching strategy, but a simple LRU is probably going to do a pretty okay job.
So you mean when the dirty extent is written to the disk and the cache is cleared?
We pretty much always just drop it at that point, which isn't necessarily the correct thing. We probably want to keep it in memory if it was recently accessed, and we don't.
Yeah, I see.
I'll add Trello board entries for these two tasks.
And the blocked IO wait alert happened when I increased the concurrency. I never met it before.
What's that?
Blocked IO wait.
Oh, yeah. I've seen that one once. Do me a favor and create a bug and assign it to me.
Oh, okay. So
I haven't reproduced that one myself.
I tried several times and meted that Ceph alert, but I never meted it before. I'm not sure if some new code calls it or it is already.
All of this code is under heavy modification. So when you hit these things, file a bug,
okay.
And that one you can assign to me. It should be pretty straightforward to track down. I think.
Okay, thank you. Well, that's all. I take some days off last week, so not much work to do.
Cool. All right, Greg, what's up?
I don't have anything really exciting to talk about, I think, but you and I need to schedule a meeting for Thursday, I think we'd said, where we're going to start talking about multiprocessing. So
afternoon, unless you have some need for more specific scheduling.
Cool. Sounds good.
All right, Tian, thing. Do you have anything you want to talk about?
Oh, sorry. I have nothing more to update so far because I'm taking the holiday last week. So in the next
Okay.
week, maybe I can, yes. As Truman is continuing the testing on the SeaStore, I will work on my retune profiling, along with the setup, like Truman, to see what's going on there and the bottleneck in the SeaStore. So that's the plan here.
Cool. Shoaib?
Last week I pushed the multi-device support PR. Right now I'm trying to modify the PR as Sam suggested. I was also trying to add a simple extend placement strategy into the EPM, like the one used in Waffle. Actually, it was a garbage collection strategy. That's all for me.
Cool.
Oh, by the way, about the bug that Treme mentioned, I met it once, and I think the situation was there were two transactions doing await hard limits on the segment cleaner, and after the future result, one of them did the IO and caused another blocked IO wait to be set, and so when the second transaction is scheduled to be executed, it found the blocked IO wait promise is
Yeah, that
set
sounds
again.
right.
Yeah. So I think this might indicate we need a complete standard condition variable.
We don't hold a lock in segment cleaner, so no.
Okay.
And I don't want it to hold a lock.
Okay.
So a traditional, so the thing that a condition that, sorry, it's in segment cleaner, right? Blocked, find the line. Blocked IO wake, right. Yeah, conceivably this could benefit from a condition variable, but I honestly think there's going to be a simpler fix. The reason why there isn't a condition variable in SeaStore is because you literally can't implement a condition variable correctly with a standard threading environment without it being baked into the pthreads library. That isn't really true with SeaStore because you can count on atomicity of anything that doesn't return to the reactor. So most of the time it won't be worth the complexity to use one. Anytime you feel like you would benefit from it, though, go ahead. In this case, though, I'm going to evaluate what actually happened and see if that's the simplest way to fix it.
Okay.
All right. Is there anything else? All right. Have a good week. Later.